Hello YouTube viewers, welcome to my channel S2T. In today's show, Future Friday, we're gonna talk about plastic waste to fuel. So let's dive right into it. Well, first we have to understand what the heck is plastic. Now, plastic is a wonder material. We basically begged science to give us something which is better than metal, which is better than wood, and we got it. Basically, it is as close to wonder material as we're gonna get. It's flat out amazing in terms of its property, in terms of its reliability, in terms of its durability. It's basically unbeatable. Now, how the heck it's made? It's not magic, thankfully. It's made out of same thing as life made out of carbon. Basically, it has carbon plus hydrogen. That's almost 99% of it. That's it. Like no matter which plastic you see, which format of plastic you see, most of the time is basically hydrocarbon 99%. However, we do add some extra to it. In some scenarios we add oxygen to it, in some scenario we add copper to it, in some scenario we add something else. Now that extra is very dangerous, but hydrocarbon is the basic part of it. That is the blockchain that builds this. Now it is better than every other option. In simple terms, think of it this way: the sole reason our humanity went from living around 60 years to living 90 years as of now is simply because medicines became practical. Now how the heck they become practical? Now again, there is a lot of science in medical basically development itself. However, you also have to understand about the delivery. Syringes were used to be made out of glass. Now, if you have to vaccinate, let's say India, you're talking about 1 billion glass syringes that you're gonna need. Yeah, that's not gonna happen. So that is why plastic played an important role in our life. Basically, medicines require to be very basically contamination free. They get contaminated way too easily. Now, what is the best substance to do that? Plastic. That's the whole reality of it. Plastic is amazing. Now that's the biggest problem of plastic. It's simply because it is amazing, it is also indestructible. Basically, there is no force of nature right now that can handle it directly. It's like flat out nothing we can do to it. Like if you dump it in ocean, ocean cannot break it down. So understand that. Like it's flat out indestructible. Like you bury a human body, it's gonna disappear in few months. You bury plastics like I don't care, like 100 years, 200 years, or sometimes thousands of years. So that's the reality of plastic. So how do we make this wondrous material? Well, we need hydrocarbon. So best source of hydrocarbon is petrochemical. So when we take crude oil is very heavy per liter wise. Now we fractionally distill it. Now again, we get your diesel, your gasoline, your jet fuel, all that jazz. You get there. Those are liquid fuel out of that. You also get some gas out of it. However, after that you have a lot of heavy chemicals left. Those chemicals are defined as petrochemical. Now these chemicals build the foundation on which we build plastics. These are not plastic. Basically, you cannot go to a fractional distillation plant. It's like tap plastic gonna come out. That's not happen. But it's the stock material of it. Now that makes all plastics that you see, almost 99.99% of the plastic that you see, literally coming from fossil fuel. Fossil fuel is playing a very crucial role in our plastic production. However, there are engineers, scientists who have worked on the greener alternative where they're like, what if I don't want to import fossil fuel, or what if if fossil fuel runs out, because it's not going to run out today or tomorrow, but it will run out sooner or later. So planning for that is a very good idea. We have done that. We have options where we can use like cellulose from wood to algae-based livestock, best of which are based on seaweeds, things of that nature. We have organic pathways of taking hydrocarbons presented in nature and make them into plastic. That's doable, absolutely true. However, they are way too expensive right now, and the sole reason we don't utilize that is simply cost, because petrochemical based, even though you may have to buy, let's say, a feedstock of, let's say, 10 ton, you may be making 500 tons of plastic out of that. So that's the reality of it. It is a very cheap, flat out. It's like it's relatively free. To give you a simpler context of this, think of this way: like you buy any drink, any beverage that you want to drink, and you are like, okay, what is the cost of that beverage in a basically aluminum can versus a glass system versus a plastic can? Plastic can will be the lowest price. Why? Because it's cheap. Plastic is free, relatively speaking. That's the production of it. Now because it's amazing, because it's cheap, we created way too much of it. That led to pollution. Now because how do we handle our stuff? We simply bury it. Why? Because microbial life forms, they are good, they know how to handle big complex thing. They break it down, they got it. Like after bury a lot of human poop in one place for, let's say, 100 years, after a while that place will become an Eden. Why? Because microbial life form will break it down, make it into something digestible. Plant life will love this. Like we have a whole ecosystem of microbial life which handles this. Plastic, it has nothing. Like microbial life cannot even touch this. It's like flat out nope. So that's the first problem. Second, oceans, like you dump it in a river, it goes to the ocean. Now oceans also cannot handle it. They do not have life forms that can handle it. They do not, like, as a physical force itself, it only shreds it. Basically it takes the plastic that is, let's say, plastic bag or bottle, they shreds it into smaller pieces, nothing more than that. They cannot chemically break it down, and life cannot basically degrade it. That's the whole thing. That is the reason why you can bury a human body or a organic waste and don't worry about it, while doing so with plastic is very, very dangerous. And because it has contaminated the ocean already, and the fact that ocean has started to make it into microplastic, it has already reached our table spoon, basically, because salt is contaminated, because fish is contaminated. At this point in time, you are eating on average one credit card per year at this point in time. As it will go up, we will start to see the health effect. Right now it's almost very minimal. So it's flat out, life cannot digest it, and life cannot manage it. It's not even like, okay, if it goes in our body, that's like, it's an inert thing, it's not going to do anything. No, it's going to flat out destroy us over time. It's not there yet, but over time it will do that. That's the biggest problem. Like, we wanted magic, we got magic, and we cannot handle it. Thankfully, because it's made out of hydrocarbon, we can make that into an actual liquid fuel. Now plastic is basically in solid form, not because of temperature, it's in solid form because of its molecular chain. It's very stable. What if we make it destabilize it? Plastic is hydrocarbon, flat out, and hydrocarbon is basis of all fuel that we use right now. So we utilize a tool known as pyrolysis. Now what the heck pyrolysis is? Basically, if you start heating something up, generally you will have evaporation and basically vaporization. Now after that, you reach into a pyrolysis point. After that, you reach into oxidation when you are doing it in open environment. Now what if you reduce the oxidation part? Basically you remove oxygen. Oxygen sets things on fire. Basically they oxidize. What if you remove oxygen? What happens then? You heat it up, it gets charred. Now what is happening after that? Once it's charred, once you have evaporated all the water out of it, something interesting happens, especially around 3 to 100 degrees Celsius to 400 degrees Celsius. It starts to break down chemically. It's not going from solid to liquid. You are not melting it, you are breaking it chemically. So what happens at that point? At that point, you are basically distilling it into smaller hydrocarbons. What does those hydrocarbon mean? This simply means you are making diesel out of it. That's the point of it. Again, there will be some gases also, and generally those gases are flammable. So what companies do when they are making a distillation plant, this is quite simple operation. They basically pipe that back into the furnace part, so they get more efficiency out of it, and they get liquid fuel out of it. That liquid fuel can be burnt directly, cleanly. Now when I say cleanly, I mean relatively compared to any other fossil fuel. It's not clean as in, like, hydrogen. It is clean relatively. So pyrolysis is a very simple trick. Basically you get your garbage, get your plastic, put it in a sealed environment, and you seal it. Also has to be sealed from oxygen, because if oxygen is there, it will release some very serious contamination, or worst case scenario, set everything on fire. Now generally for sealed environment, people wanted to use helium, but helium is not necessary. You can utilize that normal atmospheric nitrogen for that. So that way you are quote unquote burning without oxygen. That there is the chemical bond that gives you liquid fuel. Now this fuel, if you want to, you can process it into an actual high grade fuel. What does high grade fuel mean? Simply means you can put in your car, your jet plane, whatever you want to do. It's not ready yet. Like if you want to burn it in a, let's say, burner or furnace, it's good, it's like, it's awesome. But if you want to use it in, like, a car or a generator or a jet plane, you have to understand those fuels contain a lot of additives and extra properties that are made there for that specific engine. So for that reason, you cannot just directly pour it into your car. Your car will work, but it's not good for your car for very long, especially because it also has other oils, so their interaction is very tricky. So we can make liquid fuel out of it. Thankfully, the technology to do this is relatively simple. It only requires pressure vessel and does not even require way too high temperature. I mean, you're talking 400 to 500 degrees Celsius, like 600 if you really want too much gas output. So it's surprisingly easy to do, and college students are capable of doing this. It's not like some medical technology, like, where you have to have PhD on top of PhD to do it. It's simple. Then we have another aspect. If you are going into so much steps to make it into a fuel, why not burn it directly? This is a feedstock of fuel. Why not burn it itself? It can be done, absolutely. Should it be done by you? Hell no. Why? Because if you burn it at low temperature, aka you just set it on fire, it will be burning at very low temperature, aka below 800 degrees Celsius, aka toxic compounds will be released into atmosphere, which is classified as volatiles, which in turn directly causes what we call cancers, because they release way too much of what we classify as carcinogenics, basically things that can corrupt your DNA's replication algorithm. So flat out not a good idea. However, something interesting happens because it's mostly hydrocarbons, so 99% is safe, quote unquote safe. But that 1% that we add to make the plastic transparent, or we add to make plastic more malleable, those things are the contamination aspect of it. But they are generally compounds. They are very complicated compounds. So you burn it, you break it down into the smaller chains. That can be done at 800 degrees Celsius. So if your furnace is burning at higher than 800 degrees Celsius, you are safe, flat out safe from any contamination. So which is better than burying it in the ground, because not only burying in the ground releases methane, which is much more potent than carbon dioxide, and it also contaminates the groundwater. Here you don't have to worry about that. 800 degrees Celsius plus is basically safe, quote unquote safe. Now again, you cannot build a furnace that is like every square nanometer of this inside the furnace is like burning at that temperature. Some will be shaded, something, it happens. It's like combustion instability is a real thing. So what can you do? You can send the exhaust gas to a flue gas treatment. Basically you are washing the exhaust gas. Can it be done? Yes. Has it been done? Absolutely, because this technology was built for cleaning the exhaust of a coal power plants. And that is why people don't have like cancer as they used to in 1980s. So this is a normal. Both of these technologies exist right now, and Sweden is loving this because they flat out created this and it works. The reality is it flat out works. Now plants were very expensive because it was an experimental plant in the first day, and government went hard on regulations. Like the exhaust were regulated beyond a certain point. It's like, okay, if coal power plants has to have this much emission, you have to have this much emission. Now they achieved it. Like the companies, they put so much money R&D into it, they achieved half of that. So flat out compared to coal power plant, this is good. So that's amazing part. Then they started to directly use the electricity coming out of it. Electricity is a profitable thing. On top of that, because Sweden has like what you call district heating, aka there is a central pipe grid which circulates hot water. They use the waste heat from that. So they created effectively what is classified as CHP, concentrate, basically combined heat and power. Benefit, much higher efficiency. So let's say the chemical stock itself had 100 megawatt, they were getting useful energy out of it around 60 to 70%. That was amazing. Now that is why it's one of the simplest option we have, like just burn it. But it has to be burned at 800 degrees Celsius plus, and the exhaust must be sent through flue gas treatment, should not be exposed to the atmosphere. Now will that reduce the emissions, pollutions and all that? Absolutely. Will that reduce it to zero? No, but it will go as close to zero as we can get. Now this is the best solution so far. Now I am starting to hate environmentalists simply because they are not bad people, nor they have like their heart in the wrong place. They are suffering from what we call as short-sighted. They're like, okay, I can see 5 minutes ahead and not 5 years ahead. Like they want to ban plastic. Okay, here's the deal. How the heck you gonna convince people? Okay, your medicines are 10 times more expensive simply because I banned plastic. That's not something that you can sell. Oh, you're not gonna get a syringe because we have to make glass syringes which are much more expensive, which we have to sterilize because again these are not used and throw, all that jazz. And again, food transport from factories to your home is far more efficient because of a plastic. There is nothing else that is like water resistant and airtight at the same time while being so light. So every container you will build, be it out of steel or paper, good luck with that. Let's say you do that, you have to basically make sure it's sealed from the outside from something another thing, right? Rather than just plastic bag your food, it will be like your biscuits, air packet, then on another sealed container. So you will be wasting energy in terms of transport. So reality is plastic is a wonder material. We wanted it, we created it. It's amazing. We have to just handle it. Basically, we have to create, use, and burn. That's all we have to do. Now we could burn it directly in an incinerator, in a good incinerator, or we could convert it into a liquid fuel, then burn it somewhere else. That's all up to you, basically individual scenarios. I'll prefer the fuel options for small scale. Basically, if you are working like around 500 kilograms of plastic, small scale, good, cheap, efficient. Furnace one, they generally make sense if you are making huge. They are not that effective on a small scale. So again, that's up to you, and that handles it. Now because if you stretch this timeline to let's say 500 years, what are you gonna have? Sooner or later we're gonna run out of fossil fuel. What are we gonna do then? Are we gonna stop plastic? Hell no. We're gonna create biodegradable, not biodegradable, like bio created plastics, basically from algae or seaweed. What do we do then? Then we have a complete closed cycle. Basically, solar energy creates bio life forms. Bio life forms are created in plastic. Plastic releases carbon dioxide. Carbon dioxide is absorbed by next generation. So complete closed cycle. So we're gonna have our plastic, and we're not gonna have our pollution. Amazing thing. Now again, this is not something, oh, I'm gonna start today, tomorrow that's gonna happen. That's gonna like 500 from now. But we can, in the meantime, we can remove basically ground contamination, methane contamination, ozone pollution, and we can properly eliminate microplastic, which is flat out unhandleable. Like there is nothing, no technology we can employ that can handle microplastic. And that's the microplastic that we have already put into the ocean. I'm not even gonna try to think about how much we're gonna put if we don't start burning our plastic right now. Flat out, that's the real deal. And we are gonna make plastic, we need plastics. So we have to handle it wisely, basically make it, use it, destroy it. So, and the setup, like now many people might be like, what about plastic recycling? The sole reason plastic is cheap because its energy constant is cheap. We recycle aluminum because aluminum comes out of the ground. We don't have way too much aluminum. Aluminum is not like, oh, you drilled here, you're gonna get a lot of aluminum. Aluminum does not work like that. Mines have dried out and aluminum costs have been constantly going up. So it makes financial sense to recycle it. Same with glass. Glass is so complicated, so expensive, and they recycle so easily. They're like, yeah, it's practical. It's good for your pocket. It's good for the economy. It's good for the environment also because you're not consuming new material. But for plastic, that does not apply because it's so cheap. It does not apply. Like, then what about the companies that are recycling plastic? There are many companies doing so. There is a government incentive to show that you are utilizing certain percentage of your product is utilizing what we call recycled plastic. Now, not 100%, certain percent. What does that certain percent? That depends on your lobbyist. So what happens is like Coca-Cola, Pepsi, or things of that nature, they're gonna have like, let's say 500 tons of plastics were consumed. They're like, okay, add 5 tons of recycled plastic. So they get that stamp, that absolute awesome stand of 3 triangles. Yeah, because they used 5 tons out of 500 tons of recycled, technically they are recycled. They get tax credit, or sometimes like, just feeling good, brownie points and all that jazz. So practically it's just not feasible to what we call recycle it properly while making financial sense. It does not work. Like, see any plastic recycling plant, you'll be like, okay, now I get it why it takes so much. It's like same way, like why don't we recycle paper more? Because the steps required to make new paper, it's basically less than the steps required to make a recycled paper. That's why recycled copies are more expensive than normal one. So this setup is much more simpler than recycling system, and it makes profit. Basically, you can go to any communities. Like, there are many communities in India that tried this. You can see the video down below, and it works flat out. They're consuming 500 kilograms of plastic. They are making it into fuel. That fuel they are selling for very cheap price, around 15-17 rupees per liter, which is like less. You're gonna get 10 liters for around 10 liters for around $2 or something like that. So it's very cheap fuel. They're selling it, they are making profit, everybody is happy. No more microplastics. And what about the fumes that are being released after you make it into, let's say liquid fuel? Negligible. Like, compared to basically fossil fuel, negligible, because fossil fuel have a standard for sulfur content, and the company that made this, they got their fuel tested again and again because the sulfur content was 0. We don't use that much sulfur in plastic. So that's the reality of it. It's flat out better. And compared to microplastic, it's infinitely more better. And once we stretch it to far enough in future, we can be like, okay, we have a completely closed cycle. We have a wonder material, we don't have contamination issue, we don't have microplastic issue, we just have a complete cycle. So this is the best solution, and none of these require like billion trillion dollars. Like, especially the fuel one, there are people who are building in their backyards. It's that doable. Again, you do want to make it out of like good high quality parts, so you get a high efficiency, but you get the point. It's magical, a normal thing. Now incinerator is a bit more expensive because 800 degrees Celsius is something difficult. Pyrolysis only requires 400 degrees Celsius, so 800 degrees Celsius, that's tricky part. And again, you want to have a constant supply, so you can keep burning it regularly. But that's the reality. Like, compared to every other alternate is like reduce plastic use. To what extent? Like, you gonna reduce it by what, 10%, 12%? Like, it's not gonna make an impact simply because you're gonna consume biscuits, you're gonna consume medical supplies. All these things are consumables. Plastics that are the biggest weight comes from single use scenario. We can solve it. So that is why I'm really hopeful with this technology, simply because we wanted plastic, we got plastic. We just forgot to handle it at the other end. It's like, yeah, we made it, we used it, we forgot about it, and then plastic is like, bro, I'm indestructible. So this was my presentation on how to handle plastic. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.